See, earlier I told you that any matrix can be converted to a matrix of this form, which means if you have given any matrix, you can somehow do some transformations, these elementary transformations, and then get this form. So this is also called as normal form. So what is the main use of converting in a matrix to this normal form is, once you convert to this normal form, then it will be easier for you to determine the rank. There is no other use, only to find out the rank, but there are better methods to find out the rank. That is why I don't suggest that you follow this method, but just to prove that point that any matrix can be converted to a matrix of this form, I'll be taking one or two examples, not many, just to make that point clear. Okay, so what I mean to say is, you can take any matrix and apply elementary transformations and then get this form. Okay, but then never use it to find the rank, because it is very lengthy. Using echelon form is the easier way. Okay, fine. So let's see this example, and then I'll tell you few points about it. See this. So the question is, reduce the matrix A to the normal form, this one, and hence determine its rank, where A is this, which means they wanted us to apply some transformations on this matrix A and then get such a matrix. Okay, so for that, what I'm trying to do here is, you can apply any transformations. Main thing is this: make this element as 1. I mean, take the principal diagonal elements 1 1 and then make it as 1, and using that element you try to make all the elements below it as 0, and if possible you make the elements here also as 0. And next step is, make this one as 1. Right, after these transformations, if it changes, make this one as 1, and using this element make all the elements below this as 0, and make all the elements here 0 if possible. Okay, and similarly do all of that, making every element 1 1 2 2 3 3 4 4 as zeros, as ones, and using that element you make all the other elements as zeros. That is the basic method that I have used. Okay, now see this. Now I am applying certain column transformations, elementary column transformations, so that I'll make this entire first row as zeros except the first one. Okay, after these transformations, you can see that all these elements have changed, and along with that other elements have also changed. Okay, and next thing is, using this element only, I want to make all the elements below this as zeros. So for that I am using only one transformation, that is enough, because anyway these two are already zeros. So if I apply this transformation, I got here as 0, right? And next one is, I'll try to make it as 1. So for that I am just exchanging these two rows. If I exchange row 2 and row 4, I am going to make this one as 1. Yes, this one is made 1. Now using this one, I'll make all the elements below it as zeros, right? Therefore I'll use these two transformations, and this is what I got. Okay, and next thing is column 3, and next thing is these two columns has to be exchanged, because I want some element here, otherwise it cannot be in the form, we cannot get 1 here. So for that reason I am just interchanging these two. So I got it, and after interchanging this, I'll divide this column with -2, and I'll divide this column with -8. Then what do I get here? Here I get -1 and -2, and here I get 1. So everything other than this column will be in the normal form. So I just use this one to make this -2 also as 0. For that I'll use one more row transformation. So after applying this final row transformation, this entire thing is possible. Now if you observe this is in the form of I4. I4 is nothing but, here you can put I4, and there is no need of this. So this matrix is equivalent to I4, and we know that the rank of I4 is 4. Therefore we can say that this matrix and this one, they both are equivalent. Okay, what is equivalence is, if two matrices have same size and same rank, they are called equivalent matrices. And after applying elementary transformations, whatever matrix you get, that is said to be equivalent to the earlier matrix. So this one and this one, both are equivalent, and the rank of this one is 4 because rank of this one is 4. Why are they equivalent? Because we got one from the other by applying elementary transformations. And why should that rank be 4? Because by applying elementary transformations, rank does not change. Therefore, if the rank of this one is 4, rank of that one is also 4. Now, some other questions will also be possible, saying that prove that two matrices are equivalent. So how can we prove it? Find the ranks of both of them, and then we can say that if the sizes of the matrices are same and the ranks are same, they are definitely equivalent. How? Because if they are of same rank and same size, they can be transformed to the normal matrix of same form. And whenever you get two matrices which from the same normal form matrix, then of course they are equivalent. Okay, we shall see some examples on that as well. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.